For the final part of this problem, it says, hence or otherwise, find one point on L2 which is the square root of 3 units away from C. So this is a hence or otherwise problem. So basically this is suggesting that we use information that we already found to kind of help us figure this thing out. So this might seem kind of confusing at first, but let's think about what's going on here. The line L2 looks something like this. I don't know what it actually looks like, but let's just say it's this line here. And I have some point C on this line. The hence or otherwise gives me a clue that I'm going to have to use prior information. And there's a whole reason why we found that unit vector in the previous problem in 1e. I know that the unit vector in the direction of L2 is given as -1 over root 2, 0, and -1 over root 2. What I can do here is I can create a new equation for L2, a new vector equation that uses this direction vector and the coordinate for point C. Now recall the coordinate for C is given as, I could write the position vector for coordinate C as 8, 11, -1. So I can create a new equation, which is also the same equation, or it expresses the same line. This is still L2. L2 is going to equal this position vector, 8, 11, -1, plus some scalar s times the direction vector, -1 over root 2, 0, and -1 over root 2. So this equation is the equation for L2. It just looks a little bit different. I just have a different point in here, or a different position vector, or starting point, and I have a different directional vector, but it's in the same direction. The only difference here is that this directional vector has a size of 1. Now, why is that helpful? Well, if I wanted to move 1 unit away from the position of point C, I would just have to use an S value of 1, since I would be moving 1 unit length away from this point here. If I wanted if I wanted to go 2 units away from point C, I would add 2 unit vectors. So here's 1 unit vector, and here's another unit vector. So I would use a 2 for my scalar value s, which would mean that I'm adding a size of 2 to this position vector here. If I wanted to go 3 units out, this would become 3, and so on and so forth. So basically, what's nice about this equation is I'm just adding unit vectors depending on whatever my parameter s is. So in this case, I want to go the square root of 3 units away. So what I need to do is I need to set s equal to the square root of 3. And then I'm just going to plug away. So the position vector xyz is going to equal 8, 11, -1, plus the square root of 3 times 1 over root 2, 0, and -1 over root 2. Let's kind of combine this into one position vector. And this is going to be given as 8 plus -root 3 over 2, 11 plus 0, and -1 plus -root 3 over root 2. And I think this is actually a square root of 2 here. So this is kind of an ugly number, but I can just type this into the calculator and get a decimal approximation. So this is going to be the position vector of 6.775, 11, and -2.225. It looks like I'm done, but I actually am not quite finished because I want to find a point on L2. So these are the right numbers. I just need to express this as a point. So my point is going to be given as 6.775, comma 11, comma -2.225.